Hello, my name is Raphael Messi and this presentation is for Unit 3 Professional Practice. Today I will be presenting my part of the Project Mass Conference proposal from Blackhole Explorations. My role in this is the Research Support and Innovation Analyst. The focus of this presentation is artificial intelligence, robotics, automation, and how these technologies could support future Mars explorations and colonization. Instead of only looking at the conference as an event, my role is to support the project with research and analysis. This means looking at which technologies are useful, realistic, and suitable to present to the target audience. As research support and innovation analyst, my role is to support the conference with clear research about Mars automation and AI technologies. This includes looking at different technology options and deciding which ones are the most relevant to the Project Mars conference. For example, I looked at topics as autonomous robotics, habitat monitoring, maintenance, and mission planning AI. My role is important because some of these topics can be very technical. The conference audience may include both technical and non-technical people, so the information needs to be clear and understandable. The main outputs from this role include a short research brief, innovation comparison, vision summary, and contribution to the presentation materials. The main research question behind my analysis is, which AI automation technologies would offer the strongest value for future Mars operations, and how can those technologies be explained clearly within the Project Mars conference? To answer this, I focus on four main research areas. The first is autonomous robotics. This includes rovers or robotic systems that can explore, inspect, or complete tasks without constant human control. The second is habitat monitoring. This focuses on using AI to monitor things such as oxygen, temperature, pressure, power, and safety conditions in the Mars habitat. The third is predictive maintenance. This means using AI to detect early signs of equipment failure before serious problems happen. The fourth is mission planning. AI. This can support scheduling, resource management, and decision making during missions. It judges areas based on usefulness, reliability, risk, human oversight, and how relevant they would be to the conference audience. There are several automation technologies that would be worth highlighting at the Project Mars conference. Autonomous rovers could support exploration and inspection. They can travel across difficult terrain and collect information without putting humans at risk. Robotic construction could help with building habitats and carrying out maintenance. This would be useful because Mars missions would have limited human labor and high-risk working conditions. Habitat monitoring AI is one of the most important areas. If people are living on Mars, systems will constantly monitor oxygen, pressure, temperature, energy, and safety conditions. Predictive maintenance is also valuable because equipment failure on Mars would be extremely dangerous. AI could help detect problems before they become serious. Mission data analysis can help process large amounts of information quickly, helping teams make better decisions. Communication support is also important because messages between Earth and Mars can be delayed. AI could help prioritize important information and manage communication more effectively. When comparing the different technologies, it is important to think about both strengths and limitations. Autonomous robotics are useful for explorations and inspections. Their main strength is that they reduce human risk, but they need reliable decision rules to avoid mistakes. Habitat monitoring AI is useful for life support safety. Its main strength is real-time alerts, but the system depends on accurate and trusted data. Predictive maintenance helps protect equipment, ensures that it can prevent costly failures, but it needs reliable historical and sensor data to make accurate predictions. Mission planning AI can improve scheduling and resource use. It stresses efficiency but still needs human approval because high-risk decisions cannot be fully automated. Based on this comparison, the strongest focus for the conference would be habitat monitoring AI combined with robotic support. These topics are easy to explain, relevant to safety, and practical enough to demonstrate to the audience. My recommended innovation team is AI-assisted automation for safer Mars operations. This team fits Blackhole Explorations because it connects directly to Mars colonization and AI innovation. It is suitable for both public engagement and professional discussion. For example, students can understand the basic idea of robotics and sensors supporting Mars missions. where researchers and professionals can discuss the technical and ethical challenge in more detail. This theme could be used in different parts of the conference. A keynote could focus on automation as a foundation for mass element. A workshop could ask attendees to design a simple AI monitoring system for a mass habitat. A public exhibition could include robotic sensors, dashboards, and visual data displays. A panel discussion could focus on the ethical use of AI in high-risk space environments. This gives the conference a clear theme that is innovative, realistic, and relevant to the future space exploration. A key part of my role is turning research into materials that the audience can understand. One output is a research brief. This would summarize mass automation technologies and explain why they are relevant to the conference. Another output is data infographic. This will visually compare AI and automation options, making it easier for non-technical visitors to understand the information. The presentation itself is also a communication output. It helps Blackhole Explorations and conference stakeholders understand the research in a structured way. Posters and leaflets can also be used to attract attendees and explain the main ideas in a simple and visual format. Also, there's the option of a YouTube video, for example, the one that I'm making at the moment. The aim is to make complex mass technology understandable, while still keeping the professional standard expected by Blackhole Explorations. Research and innovation also needs to consider ethics and risk. AI failure is a major concern. If an AI system makes the wrong decision in a mass mission, it could affect safety forever. This means human oversight and backup systems are essential. Data quality is another issue. If the data is poor, the AI predictions will also be poor. Sensors need to be tested and monitored carefully. Bias and assumptions are also important. AI trained using Earth-based data may not work perfectly in mass conditions. This means systems should be tested in simulations and updated with relevant data. Transparency is also necessary. Stakeholders need to understand what AI can do, but also what its limits are. The research role is just to find exciting technologies. There's also the question: those technologies understand their risk and communicate them honestly. To conclude, my role as a research support and innovation analyst is to turn mass automation research into clear evidence that supports conference planning and decision making. The strongest conference theme I identify is AI-assisted automation for severe mass operations. This theme is supported by robotics, habitat monitoring, predictive maintenance, and mission planning AI. The research shows that these technologies could help reduce risk, improve efficiency, and support future mass missions. For Blackhole Explorations, this creates a conference theme that is technical, understandable, and relevant to future space innovation. This project has also helped me understand the importance of research, communication, problem solving, and professional development. Thank you for watching my presentation.